Today is verification and validation on the design control series. Thanks for coming to the webinar. I'm going to talk through creation of evidence around our compliance with the set of requirements and some of the challenges associated with that. I'm going to try and do a better job of answering questions this time around. So I've got my question set up. So if you feel the need or have any questions as we go along, please feel free to drop it into the question box. All right, so that's how we're going to start. I'm going to go ahead and move on. So major design control capabilities. I'm just again for context, really requirements management is the core of this system, and it's what all of these different capabilities pivot around. In the past, we talked about systems modeling and management of standards. Now, today, we're talking about verification and validation as it contributes to that requirements model. So in order of methodology, I like to think of requirements management and systems modeling as the core. And those aspects of the system sort of provide the foundation. Then we enhance it with these other capabilities. So standards management, verification and validation, and risk management are all sort of aspects of looking at requirements that allow us to create a more complete requirement set. What we're really looking for is a set of requirements that considers risk, systems modeling, all the external standards, and the evidence that we need to show that we're compliant with our definition of what is good product. So that's kind of what we're after. And I'm just going to start with this sort of very simple traceability. So if we think of what we're trying to establish in a design, we want to establish the function, the outputs of those functions, which is a requirement, and the requirement characterizes what that output of the function needs to be, or functional chain or capability. What are the outputs that black box is creating for us? And the requirement characterizes what that output needs to look like. Then we develop a set of test cases and test results to show evidence of compliance. And then finally, I'm going to spend a little bit of time on this today, is what are the outputs then? What is the physical representation of the design, and how does that relate to both the requirements and the test results? So we need to get to a place where we have a better understanding physically of how we're satisfying those requirements and build that into the reporting structure. So when we talk about the CFRs, this 820.30F is where design verification comes from. This is really the requirements piece of it, where we say it shall confirm the design output meets the design input requirements. That's sort of requirements. But I would propose that the second, which is the validation, section G, says that we shall ensure that the devices conform with defined user needs and intended uses. And I would argue that this is more of a function question. How is it that what function does the product need to deliver for users? Not so much how have we, from an engineering standpoint, broken it down, but functionally, what are we trying to deliver? Now, of course, we have functional requirements, and that confuses things a little bit. But what I'm really saying here is we need to consider function so that when we get a non-conformance in the field and it's associated with an output or a test result or a requirement, we really want to understand what the impact is to the function as well. So this sort of simple traceability, I think, is important to include function and all of the different aspects, requirements, test results, and outputs. So again, we have this V-model decomposition, and the V-model decomposition, a lot of times when people see this, they think in terms of workflow, that I need to do the user needs before the system requirements, which are then done before the design requirements. That's really not what this is intended to do. There's nothing that says that we can't put in a bunch of design requirements from a standard and then link it into the system requirement as it's created. We're not really talking about what's being done first here as much as we're talking about how to decompose the design in a way that gives us a full picture of what it is, what is a good device. What if we wanted to characterize what a good device is, how would we explain it to someone on the outside how the device functions? And of course, these refinement relationships inside the different user, different requirement types allows us to have a much more complex design in a simpler data structure. So the intended uses, for example, are a a higher set of user needs. And so if we have an intended use statement, we can decompose it with other user needs. Same thing goes for system requirements. We can have system, subsystem, and sub-subsystems in any way that we want to, but it's defined by one data type. And design requirements oftentimes will have something that says the design will include the following, and then we have a list of things. So these refinement relationships allow us to have a more complicated design without getting a too complicated of a data model. So that being said, the test cases then link into the user needs with the following relationships. So a test case validates a user need, and it verifies the different sets of requirements. And the reason that we have it this way is so that each it's very clear the separation between the verification and the validation. I think it's one of the things that I want out of a system is have very clear delineation, both from the difference between a user need and a system requirement, but also when we run a test against a system requirement, what's entailed? Is it the finished device? Is it a subassembly of the device? Who are we using as the people that are the personas that are going to be doing the testing? And then in the end, what are the outputs that are associated with that? So really what we're talking about here is test management. And I'm going to get into some other terms that people use and discussions around this, but what we're trying to do is establish whether the product complies formally in a reporting structure, whether it complies with our definition of good. And this little diagram I find helpful because when we talk about all the test cases against a product, there might be 10,000 of them. And what we want to be able to do is segment those down into a test protocol and have the test cases that are associated with the topic segmented into that document and then be able to run smoke tests on it. So an example of this is biocompatibility. So we'd have a set that this 1, 2, 3, 4 would be the biocompatibility set, but maybe we only want to run cytotox as a smoke test to understand, do we believe we're going to pass the biocompatibility first with a quick, inexpensive test that gets us most of the way there. So this is really a way to segment, create test cases against the requirements that are associated with the topic, create a test protocol, then execute that test protocol to get the test results. So test management is really keeping track of what is our verdict here of, compliance of the testing against a particular set of requirements. Some of the related topics that are associated with this that I'm not going to be talking about today, but just to get it in your head is calibration's one of them, and calibration associated with test methods. So when we're doing these test cases, one of the things that we want to be able to do is utilize test methods that have been validated for measurement of a particular parameter. So are we going to use a caliper for a diameter check? Are we going to use, an optical comparator? All of these things should be rolled into the test case definition. But in addition to that, test automation. I think a lot of times when people talk about test management, they think in terms of test automation. That's a completely different thing and a whole different set of tools to be able to automatically execute against test cases and provide those results back into the system. But in the end, we need those results to come back into test management so that we have a clear picture from a reporting standpoint of whether we're compliant with that particular set of requirements or not. So we won't talk about test automation today, but test management is really the topic of concern. All right, so what I wanted to do in the talk today is really talk about what is the current state of things? What would I consider to be sort of state of the art as to how people have deployed these systems? And also in the future, what should we consider rolling into the system? And I think a lot of times people don't think about what is the end game. And I want to kind of talk a little bit about the end game, but also talk about what is pretty currently done and also what are the gaps against what people typically do today. So this I would consider to be pretty much a state-of-the-art report where we're talking through the user needs, the system requirements, the design requirements, and then what are the test cases that we're executing against those design requirements, and what are the results that we're going to get. And those test results, the green check of each test step and then the overall verdict of whether we pass the test case or not is the evidence that we're compliant with that particular requirement. This is a much further along than most people have. Very typically, I see in industry, so maybe 60% of the people out there do this all with Word documents and spreadsheets. The people that don't typically have two different systems. So they'll have a requirements management system and they'll have a test management system. And to get this traceability report is really a very manual, difficult process. This represents integration of those two things together so that we have one report that shows compliance against the requirements. Now, design outputs is a part of this, and in this case, we're using an artifact inside of the requirements management tool to identify what the output is that we're showing as compliant. But you notice here that we don't have revisions. And the revisions are kind of critical to this because we need to understand what is the device under test that was used as part of this, running this test. And the reason for that is because we want to be able to establish that the DMR or the product that we've approved to shipment and the revision of that DMR has all of the testing that's been done and it's compliant. And without the revision, it's a difficult thing for us to really understand. And so I'm just going to walk through this. Okay, we have the function that's associated with the requirements. We have the test cases that are associated with the requirements, but we also have the outputs, and those outputs satisfy the requirement set. And when we do this, what we want is to understand what is the revision of each one of the outputs. So the device as a whole, the part, and the attributes of the part, and we want to associate that with a revision of the requirement. And when I talk about parts, really, I think of it in terms of my Siemens background, where we identify a part, the device is a part, the subassemblies are parts, the components of the subassemblies are parts too. It's a generic term, kind of like a work item that's used for any object that's inside the PLM system. So each one of those objects then has a revision, and when we do the test on the test case against the requirement, we want to know what is the revision of the device under test that we're using, and also what's the revision of the requirement. And in the past, when I've done this, what I've done is really had 6 inches of paper, because what happens is you go out and you build the parts against a revision set, and when you build those parts against the revision set, they come back and we do an initial inspection and some initial testing, and on some level it fails. So we might have a dimension that's out of spec, and we're either going to change the print or we're going to change the process to make the part or change the design on some level. And what happens is you end up with this churn of requirements and parts, and you have to at some point in time reconcile that the current revision of the part has the test results that we're looking for. And this is a very difficult thing to do, and it's even more difficult as we go down the road and we start making changes to the device over time. So really this understanding of what the revisions are for the requirements and the parts so that we can get the testing right is a really important part of doing verification and validation and getting a report out of this that really makes sense to kind of check it off and say it's done. So again, we have this Rev B and Rev D. We're trying to associate specific revisions of the outputs to the requirements. And when we think about the different revisions of the outputs, this is really a precise BOM. And what we mean by a precise BOM is not only do we have all the part numbers associated with it, but in addition to that, we have it associated and approved. And when it's approved for production, that's what we really are calling a device master record from a bill of materials perspective. So that DMR really is driving what the content needs to be, because we need to understand whether those particular revisions of the parts have been tested and under what conditions do we have the evidence that it shows that those parts satisfy the requirements. So again, we have revisions of the requirements as well, and different revisions for the different levels of requirements that are associated with particular function, right? So then the question is really, what's wrong with this report? And really the thing that's missing are the revisions of the requirements and the revisions of the outputs. And you can imagine that the outputs are never carried inside of the requirements management system. And the reason for that is these different databases for the different applications are intended for different uses. So the requirements management solution is really good at establishing traceability, kind of like Git, and this particular tool, Polarion, is based on Subversion, but they're really good at understanding complex traceability, branching and merging, getting to a place where we understand all these complex relationships in the traceability. What PLM is really good at is very large hierarchical file management. And so for an example, we'd never take a part and put it into the requirements management solution because it stores it as a blob and it would kill the performance of the application. And so we want to have this separation. Well, what that means is those outputs are contained in a different system almost in every case. I've never seen it actually contained inside of a requirements management solution. So we're going to have an integration between the PLM system and the ALM or requirements management solutions so we can establish those relationships to get this report. So it's a little more complicated than you might think. And of course, what we'd like in this report is to be able to establish what is the DMR we're concerned with, what's the revision of the DMR, have it pull up the outputs, and then tell us whether the testing is approved for that version of the DMR so that we have a checkoff that says we have all the testing in place, not just for this product, but for the revision of the DMR that we're concerned about approving for shipment. And this kind of backward compatibility to be able to understand those relationships is something that's very difficult. And I've seen almost no one really build out. And I think this is where digital transformation really needs to go. And of course, we get a green check that says it's all compliant. So one of the things I kind of wanted to talk about is why is this difficult? And especially in big companies, when we talk about J&J, Medtronic, Alcon, and we have these multiple divisions, usually these companies are driven as conglomerates that have purchased products over time. And we have different divisions, and all the different divisions do things differently. And so just to give you an example, requirements management solutions that I've run into, and this is only a subset, but Polarion, of course, Teamcenter has its own requirements inside of the Siemens portfolio. Cognition Cockpit, Codebeamer is now a PTC product along with Integrity, Greenlight Guru, JAMA, Jira, and the list goes on and on. There's probably 50 different requirements management solutions out there that people use. Test management, of course, you can use Polarion. Proton's one that I've run into, Jira, cybersecurity tools, but also part management. So when we talk about PLM systems, commonly Teamcenter, Windchill, Arena, Agile, and inventory management. Almost everybody I run into now uses SAP, but document management is kind of an interesting one in that we have these standard solutions like Documentum, and Viva is a great document management system. But you can also use the PLM systems to manage documents. So Teamcenter, Windchill, Arena Solutions, Agile, these are all also document management systems. So when we start to talk about this traceability to parts, we end up with a problem in that these different applications are used not only in different ways, company to company, but also division to division and product line to product line. So you might have mechanical parts, for example, that are managed as documents inside of Documentum. And then maybe you have Teamcenter and Agile that's being used. This is an example of one company that I've worked with in the past and the application set that they had. But you might use Agile or SAP as your documenting the formulation because you don't have an engineering BOM and you're going to be creating the formulation parts inside of SAP as an MBOM and you don't have an EBOM. But another example might be labeling where we're going to develop those inside of, Teamcenter, and Teamcenter has the labeling parts in the EBOM, which would then be progressed to the MBOM. And the problem is these are all done very differently, product line to product line or division to division and company to company. And so what happens is when we start talking about part traceability to the test cases, from where, right? And what applications are you using to establish those revisions? And we need to have an automated way to get into those systems to identify what the artifact is that we're testing against. And this whole idea of creation of a comprehensive BOM to me is such an important aspect of this. We want to be able to transfer into production a DMR that's a comprehensive BOM where all the different design disciplines are in the same place. And so you can imagine if I have a BOM for formulation that's different than labeling, which is different than packaging or mechanical or electrical parts. What happens is when we do that transfer, it usually comes, or very often comes, from multiple systems that's then put into SAP, and then SAP kind of has to manage the inventory of that, and we have to figure out then how to get it to manufacturing execution. It's a pretty complicated process. Much better for us to have a comprehensive BOM, so we have all of the parts in one location, and then they get transferred out to the plants as is appropriate to where they're being manufactured, rather than having all of these different applications and the mess that's associated with trying to figure out how to progress an EBOM to an MBOM. So I bring all this up because when we go back to this simple traceability, the simple traceability is from function to requirement to test results to outputs. But the problem that we run into, and this is just one example of this interface between test results and outputs, that complex traceability almost always ends up being a massive manual process. And it's really a result of the fact that we have so many different applications out there with the different formats of the data, the different data models that are associated. You're going to have a different data model for a wind chill set of artifacts than a Teamcenter versus documents that are carried in some applications. So getting all that sorted out is where people get stuck. And so first thing, when you're going to do a digital transformation and you want to understand this relationship, it'd be preferable if we had one application of a type. And so if we have a requirements management solution and a PLM solution, you can imagine that the one-to-one transfer makes it much easier. If we don't have one application of a type, and we aren't even going to attempt to do that, then I think we really want to consider a robust integration bus. And the reason for that is we want to have a common data model that we're interfacing with so that we can transfer this data in a way that makes cohesive sense to the organization. But it's something that we need to have a strategy built around. Very clear understanding of the application of a type or the different applications of a type, and then how we're going to move this data across the system. Those complex requirements traceability in one application is really helpful. So when we talk about function, requirements, tests, and standards, to the extent that we can have this complex traceability built into the tool that's designed to manage that, I find that to be very helpful. So an example of a problem of that is when we try to do test management and requirements management in different solutions, but in addition to that, a lot of times people will do risk management in one solution and requirements management in another solution. And when you start trying to do these complex relationships across different applications, it becomes untenable. It's very difficult to do. And so also we want to align the data with the application strength. So PLM systems are great at managing big files, complex files with like surface files, 2 GB files. We want to have those in a PLM system, not elsewhere. Same thing with traceability. We want those in the ALM solution because the databases are set up to handle those efficiently. And in addition to that, we want to develop a system with an understanding of what's reporting is desired for completion. So this goes back to that discussion I had a few minutes ago. I really want to be able to identify the DMR and have an understanding of are all the tests done as a result of that. And what that requires us to do is have the traceability to the parts. So this is just the type of thing that we need to consider. And then of course, consider a robust integration bus. So this is just a discussion around doing V&V and what's required, not just from a test case management standpoint and test execution standpoint, but what are we trying to establish from a reporting perspective, and how do we get to a place where we have a system that's robust enough that we can get the reporting out of it that we would desire. So that really concludes the discussion for today. We're at about 27 minutes. Did have one question about why we should bother connecting output revisions to requirements. And really, it's because the DMR VMV evidence of the shipment, we want to have a report that shows us that the DMR is that's associated with what we're trying to approve for shipment is associated with those different requirements. How they're associated, what revisions, do we have the appropriate amount of testing? And we also want a physical connection to function. So I'd like to understand for a function what physical components of the system are associated with that particular function. And if you don't have that formal relationship between the function and the outputs, I don't know from a FMEA standpoint or from a function standpoint specifically what in the device is showing compliance with that particular function. So that both of those things I think are really important. And I'll just keep an eye out for questions if you have any others. So thank you for coming to the VMV session. That was today. The next one, next week, we'll finish up the design control with risk management. So we'll go through how to integrate risk from a data model standpoint into the overall requirement set. Again, thank you for coming. My LinkedIn and email information is on this sheet. If you put in the subject information, the word information, it'll bubble right to the top of my email address if you'd like to talk, or if you want to get to my YouTube channel, this is the link. Please subscribe if you'd like. And there's a lot of content there built over the last couple of years. So feel free to roam around or drop me an email if you have any questions. So thanks again for the day and appreciate the discussion today.